Hello friends, today we are going to discuss some important questions in instrumentation. The first question is why 4 to 20 milliampere is preferred over 0 to 20 milliampere. Look friends, 4 to 20 milliampere signal is a standard signal in instrumentation and 0 to 20 milliampere is also used in instrumentation. But today we will discuss why we use 4 to 20 milliampere, why we don't use 0 to 20 milliampere. And its answer is 4 to 20 milliampere signal is preferred over 0 to 20 milliampere because 4 milliampere is taken as live 0. Look friends, if we take 4 to 20 milliampere signal and if the signal falls below 4 milliampere, suppose the signal is 3 milliampere or 0 milliampere, then it indicates a fault condition like a wire break, a loose connection or instrument failure. So we use 4 to 20 milliampere signal instead of 0 to 20 milliampere signal. In 0 to 20 milliampere system, 0 milliampere can mean either a zero process value or a fault, so it becomes difficult to identify the exact problem. If we use 0 to 20 milliampere signal and 0 milliampere is coming, then how can we recognize that this signal is a process variable signal, this signal is a fault, or this signal represents the instrument failure? So it is difficult to identify in 0 to 20 milliampere signal what exactly 0 milliampere represents. But in 4 to 20 milliampere signal, 0 milliampere clearly represents a wire break, a loose connection or instrument failure. So 4 to 20 milliampere provides better fault detection and more reliability signal transmission in industries. Now the next question, another very important question from pressure transmitter. Suppose pressure transmitter range is 0 to 10 bar. So what will be the output at 5 bar? This question will help you a lot in interviews and this question will help you a lot also in your working. Let's discuss its answer. Look friends, here 5 bar represents 50% of the range. We are taking the range 0 to 10 bar. So 5 bar will represent the 50% of the range. And output will be, it is a formula, output is equals to 4 plus 50% into 16. Here 4 to 20 milliampere means at 0% it will be 4 milliampere. So we are taking 4 here. And span will be 20 minus 4, 100% minus 0%, 16 milliampere. So here we are taking span. Okay, here we are taking 4 milliampere because signal is 4 to 20 milliampere. And here we are taking 50% because 5 bar represents the 50% of the range. If we take 4 bar, then 4 bar will represent 40% of the range. So here we will take 40% instead of 50%. And when we calculate it, it will come 12 milliampere. 4 plus 8 is equals to 12 milliampere. Next question, another very important question. What is the difference between accuracy and precision? It is also a confusing question. If we talk about the accuracy, accuracy means how close the measurement is to the actual value. Suppose we are taking a transmitter and its range is 0 to 10 bar. Now look carefully. Suppose the pressure is also 10 bar. But if transmitter represents 9.9 bar, so accuracy represents how close the measurement is to the actual value. Here measurement is close to the actual value. Suppose it is presenting 9.99 bar, so it will be more accurate in comparison to 9.9 bar. But the precision means how consistent the measurements are when they taken repeatedly. Suppose pressure transmitter is measuring pressure 10 bar repeatedly. So how many times it is showing 9.9 bar or 9.99 bar. So it will represent the precision. An instrument can be precise but not accurate and accurate but not precise. So you can easily reply the difference between accuracy and precision. The next important question related to control valve. What is the purpose of positioner in a control valve? It is mainly asked in interviews. So you must know the answer of this question. Let's discuss it. Look friends, a positioner makes the valve stem position accurate according to the input signal. Positioner is an instrument that positions the valve according to the input signal. And this input signal is 4 to 20 milliampere signal. This is the positioner and this positioner will position the valve according to this 4 to 20 milliampere signal. Suppose input signal is 12 milliampere. So positioner will position the valve according to 12 milliampere signal. Suppose signal is increased to 16 milliampere, then positioner will position the valve according to this 16 milliampere signal. And positioner reduces the effect of friction, load variation and air pressure changes. Let's move to the next question. What will happen if instrument air fails in a pneumatic control valve? Then it will depend on the valve action. If valve action is fail open valve, then it will be fully open. Fail open valve means when air supply fails, the valve will fully open. If control valve is fail close valve, then it will be fully closed. Okay. And if control valve is fail last valve, then it will stay in the last position. So it will totally depend on the action what will happen when pneumatic supply fails. The next question is very important for you. What is loop checking? Well, and its simple answer is from field instrument to DCS PLC and valve, the final control element signal path is verified by loop checking. Suppose an instrument is installed anywhere in the field and its connection is given to PLC DCS, and then the output is given to a control valve, a final control element. Then this complete signal path will be verified by the loop checking. So loop checking is a process to verify the signal path from field to final control element, from PLC to final control element, from PLC to field instruments. Now let's discuss the next question. What is the difference between HART and 4 to 20 milliampere communication? First we will discuss 4 to 20 milliampere communication. Suppose a field instrument is installed anywhere in the field, and suppose this field instrument output is 4 to 20 milliampere signal. So this field instrument will send 4 to 20 milliampere signal as the output, and it will be the analog process value. Suppose it is measuring pressure, so it will send the value of pressure in the form of 4 to 20 milliampere signal. Suppose it is measuring flow, so it will send the value of flow in the form of 4 to 20 milliampere signal. And if we talk about the HART communication, then HART communication will be this 4 to 20 milliampere analog signal and HART digital signal. Here HART digital signal will be superimposed on this 4 to 20 milliampere signal. What is the requirement of this superimposition? HART superimposes digital communication on the signal, which provides configuration, diagnostic and additional parameters. These can be accessed. If we want to access some other parameters from that field instrument, then we need HART communication. So here it is a simple answer. 4 to 20 milliampere sends only analog process value. HART provides digital communication on the same signal, through which configuration, diagnostic and additional parameters can be read. Another important question, what is an interlock? And the answer is very simple. Interlock is a safety logic. Remember carefully, it is a safety logic that prevents any equipment from starting or trips if any condition is not met. Suppose we want to start and stop this motor on a particular level or pressure, then we can start or stop this motor using interlock logic. Suppose we are measuring some parameter from this field instrument. It may be pressure, it may be level or some other parameter also. And if this parameter crosses a set limit, so after that limit, this motor will automatically start or stop according to the safety logic, according to the interlock logic. Okay. Next important question, what is the difference between PLC and DCS? If we talk about the PLC, PLC is mainly used for machine control and fast logic applications. But DCS is designed for continuous process control and has stronger process monitoring and operator functions. If we require process monitoring and more operator functions, then we use DCS. And if we require a machine control and fast logic applications, then we use PLC. The next question, it is related to troubleshooting. Suppose the DCS is showing zero flow, what will you check? Now let's discuss it. First we will check the process condition. Then we will check the transmitter reading. After that, we will verify the power supply. Then we will measure the 4 to 20 milliampere signal. Then we will check the cable continuity, and after that we will check the marshalling panel and connections. Then we will verify the AI card status. So troubleshooting should always be done from field to control loom step by step, and these are the main steps. So friends, that was our video. Thanks for watching the video. For more instrumentation videos, subscribe to our channel today. Thanks for watching the video.